theme got updated, everything is working in different manner. Okay. Why this much gap? Okay. Okay. So here it is about OSI model. I started recording on that. Yes, it is. OSI Open System Connect. Open System Interconnect. Open System Interconnect. Yes, no. Guys, may I audible?
Yes, sir.
Yes.
Yes, sir.
Yes, sir.
Okay. Okay. It is a open system interconnect. Means, guys, it's a small story. It's not big story. Only one line story. It is. We have a different network models. Okay. For example, Apple tag. We never seen that one, but there is a olden days Apple tag only work for a certain Apple based systems. They can communicate only, so they can't communicate it to other type of systems, other OS based systems. They cannot able to communicate. In another hand, so different network like IBM system cannot communicate with other type of systems. Okay, and next one is we can't understand. So different type of networks are came. We don't understand how the network is functions. Even TCP/IP is also called as DoD model is came into market, which is also we are all using now TCP/IP model. But to understand what are the model it is, how it is function, to troubleshoot what are the model of network model it is to troubleshoot, this OSI model is useful. It is a reference. Why it is reference? Okay. It's tested. So A to E. Okay, it's a reference model. It contains 7 layers. So that's why it is called as a 7-layer model. It contains 7 layers. 7-layer model it is. Okay, 7-layer model is this. Okay. Some people will read from bottom to top. Some people read from top to bottom. Some people read layer wise. But I'm giving one kind of stuff. The first is coming to the 7th layer. Okay, some people are getting it out from 7 layer to 1 layer, 1 layer to 7 layer. Which one is correct? Like in a side here in this test book, we have a layers. So we have a layers like a application layer, presentation layer, session layer, transport layer, very good, network layer, then data link layer, very good.
Telling clear.
Physical.
Last one is
Physical.
physical layer. Very good. So this is a layer 1, layer 2, layer 3, layer 4, layer 5, layer 6, layer 7. In some textbooks, some websites, some people teach us from layer 1 to layer 7. Some people write from 7 to 1. Which order is correct? Whatever the order, 7 to 1 or 1 to 7, both orders are correct, guys. Don't worry. Okay? Don't worry. When you are sending, for example, there is a device, destination is B. When you are while you are sending a request or when you are sending a data, it is 7 to 1. Okay. So you are receiving, receiving a packet up to your device, from your device. Okay. So while you are receiving, is 1 to 7. Okay. So this is the point here. It is when you do sending, while you are sending one, you are sending 7 to 1. When you receive 1 to 7, but do not interchange the layers. Application layer, physical layer. Some people they remember P but not presentation. Immediately application layer, physical layer, and the transport layer, data link layer, session layer, like that. Do not interchange the layers. Always follow sequence, either 7 to 1 or 1 to 7. Application layer, presentation layer, session layer, transport, network, and data link layer, and physical layer, or physical, data link, network, transport, session, and presentation and application layer. Okay, these are the main layers. Okay, so either top to bottom or bottom to top, both are okay. These three layers is called as a bottom layers or a hardware layers. Exactly, say hardware layers. Already we know why it is called. We have an example for this layers, right? Physical layer example is hub. Layer 2 example is router, comes under layer 3. Okay, hub, switches, stop this. This is easy. So these three are hardware layers. What about these three layers? This is called upper
Software layer.
layers. Yes, or top layers. Exactly. So it is software layers. Or top, whatever it is, no problem. But important is these three layers are software layers. These three layers are hardware layers. What about a transport layer? Transport layer is part of OSI. Okay, it is provide end-to-end connectivity. Okay. End-to-end. That is the introduction for your OSI. Guys, I am going to start with application layer, but before going to start application layer, I want to tell about a small part. Direct application layer is better, or the protocols and the port numbers. Better, we'll keep it here. Okay, protocols and port numbers are very important in network communication. So what is these protocols and port numbers? When I was in my engineering, my lecturer told me protocols means set of instructions. Yes, she is right. She is told protocols means set
Yes,
of
sir.
instructions. And example for instructions. So when lecture came into class, so you have to stand up, you have to salute to the police, okay, military salute kind of stuff. That is not exactly the example for a protocols and port numbers. Okay, you know, in networking and hardware, there is a lot of misguideline is there, guys. That's why I keep changing things. Okay, so compulsory, no better way. Of course, this is I have written already, so why should we write and time waste again? Protocols are set of rules, but what kind of rules it is? I want to send a request. I want to send a request to my web browser. So here I open a website. How this web server understand what is my request? I'm asking a web page. I'm asking a web page. So how this web server understand I'm asking a web page based on the what protocol I'm using. And also I'm also understand my client PC understand, okay, what is the server is given to you. Is it given a web page? Is it given a file? Is it given an IP address? Is it given a name? Okay, is it given any mail? How client will understand? Based on the protocol only. So these protocols are actually defines what type of communication it is. Think like this. This is your client PC and this is your server PC, or maybe some other PC, another system. Maybe it's not required a client and server model. It can be any model. You will send a request and you will receive a response. Here I am taking an example, web server kind of concept. So this is my PCA, and this is something like a web server. Name is server A. I ask a request. I send a request. HTTP request. Okay. So my web server understand what is my request. Okay. So I'm asking a web page. It will give you web page in the HTTP response. Okay. So client and server both understand what type of communication it is. Okay. And they will respond. For example, my client is send a request to the server. Oh. Okay, something SMTP. It is related to mail request. Okay, I send a, for example, a mail request. I want to access a mail server or a NTP request or SSH request. Something I send a request. What server will do? Server drop the packet. It's not a web server, right? It's not a mail server. So I send a request which is belongs to mail communication. This belongs to mail communication. It's a web server, web pages, it is there. Now mail communication. So what it will do? It drop the packet. Means what are the requests you are sending? If the server having that related service, it will respond. If the server don't have related service, it don't respond, it will drop your packet. So that's the matter, guys. So what is the protocols and port numbers kind of stuff? It represents what type of communication you want to do it. See, HTTP, it's like you're asking a web page. FTP, you want to upload or download a file, we use a FTP protocol and FTP service. SMTP for sending mails, POP3 IMAP for receiving emails, NTP is a sync the time. Okay, can you see? This is my time, which is I am getting this time from the NTP server. You want to see adjust date and time. Okay, can you see this is time server time.windows.com. Okay, from this time.windows.com server, I am getting this time based on my time zone. Based on my time zone I selected, I am getting this time from the time.windows.com. How? With the NTP protocol. LDAP, Kerberos are authentication protocols. SSH, TELNET, RDP, these protocols are belongs to remote access. Okay. So I'm going to show you certain protocols and their port numbers, which is we are generally using. Okay. We have almost so many protocols, almost more than 1023 protocols and port numbers are there. Lot of protocols are there, and of course, okay, we are all cannot able to. Of course, as per you, you have to remember things, but I will keep it this in bottom. Better keep it in one page. That is why I'm writing like this. It's also better to keep here. Okay, guys, something we missed here. Yeah, this is protocols. Certain protocols I have listed here. So HTTP port number is 80. What is this port number? So computer will process your protocols and their related services over the port numbers only, not a direct protocols. It's directly when you are sending, it's not HTTP, it will send 80 instead of HTTP protocol. Okay, so there is a dedicated port numbers for a certain services or a protocols. So that's I am listed here. Okay, HTTP protocol is used for a web communication. Okay, web related communication. HTTPS is same web communication only, but over SSL. Guys, I open a website. For example, this website is HTTP type. For example, if it is a HTTP type, whatever the data I am sending and receiving, it is in a same format, plain format only, not encrypted format. So if anybody catches my data, someone is try to catch network data, what I am sending and receiving, so they will know what I'm sending and receiving using certain tools, of course. But HTTPS, what are the data I'm sending and receiving, people don't know what is the data. Example, just for easy to understand, in WhatsApp, you have end-to-end encryption. End-to-end encryption. What is end-to-end encryption? You can see data and the recipient can able to see the data. What are the data you are sending and other person is receiving, so the data is should be encrypted. Okay, it automatically encrypted while it is transmitting from your mobile phone over the internet. It is encrypted. Once other person is received to his mobile phone, the data is decrypted and show to that person only. Any person is trying to catch your data, he cannot understand what is the content in the packet. That is HTTPS. This is important protocol, HTTP and HTTPS. HTTP port number is 80, HTTPS 443. Okay. Same protocol FTP. I am getting really bored, guys. Morning you are very good. What? Suddenly something drop out. Happen. Number of people are reduced. FTP protocol 2021, because this is an important question. That's why I'm telling. So okay. Difference between HTTP, HTTPS. HTTP data is not encrypted while you are sending and receiving. HTTPS data will be encrypted using SSL certification. Okay, data is encrypted, so your data is secure. Mainly for banking websites, social media websites, email accounts, data is very important. So no one should capture your sensitive data. So the people are using HTTPS. FTP protocol to upload and download files to the file server. So then it is FTP protocol. SSH and TELNET both are used to remote access in a command line. It is a CLI based remote access. CLI, command line interface type of access it is. Command line interface. Okay, we can access remote PC, so then we can configure work with the remote PC. For example, I have a one Linux server is there, so I want to access from my laptop, so I can access in my network. I have a Linux server. If I want to access the Linux server, I can access from it because that is act like a SSH server, and I'm using SSH client. This is remote access purpose. And this is also remote access. Difference is SSH encrypt your data. Telnet don't encrypt any data. If you want encryption in Telnet, so you have to use additional security. But by default, SSH is secure because of it is by default the protocol is when you use a protocol, RSA encryption will be works here. RDP, remote desktop protocol. So you want to access the remote Windows desktop system. You want to access from your laptop through network, you can access. SMTP port number is 25. To send a mail, when you are sending a mail, the protocol is 25. So SMTP protocol. You want to retrieve a mail, already mail is in your mail server, you want to retrieve a mail from your mail server, your request is POP3 or IMAP. Both are used for retrieving emails, either POP3 or IMAP you should use it. TFTP, Trivial File Transfer Protocol. The Trivial File Transfer Protocol is used to upload or download configuration file, backup the configuration files, kind of stuff. Remote configurations, upload or download a remote configuration files or a backup the remote configuration files. TFTP protocols are used. DHCP, Dynamic Host Configuration Protocol. Okay, what is the use of this one? It is assign an IP address to the client automatically. It means we are getting an IP address from DHCP server. Already I explained that one. DNS, domain name system. Okay, so when you are accessing a remote server with a name, Okay, when you are accessing a remote server with a name, so we don't have an IP address, right? We don't know this particular server IP address. Who is giving an IP address of w3schools.com is DNS server. NTP, already I told, network time protocol, which is setting my time. So time.windows.com is my time server, which is synchronize my time with that one based on my time zone. Okay, Kerberos is an authentication protocol. LDAP is also authentication purpose. LDAP is a more open protocol type, but Kerberos is mostly used in Active Directory environment, Microsoft servers only. SNMP. SNMP is a monitoring related protocol. Okay, used in monitoring kind of stuff. It's a port number or 2. If you see, observe, some protocols are only single port number. Some protocols are having double port numbers. So why? Because of like sending and receiving. For sending one protocol, for receiving another protocol. Okay, like client to server, server to client. Sometimes certain protocol use 2 port numbers, certain protocols use single port number only.
Sir,
Tell me.
Active Directory means the printers, the computer. That's not a word. Used in
So
Active Directory.
in domain environment means our laptops are work group PCs. Okay.
Yeah.
So no centralized control, but in Active Directory, all your user accounts, computer accounts, we maintain in a centrally. Okay, centralized authentication
Centralized.
to access your computer or a printers or anything. So centrally authentication is there. Centralized authentication.
Okay.
Okay. They added one more that is called MySQL port number is 3360. No guarantees here, so you can add some more kind of stuff. Oracle listener. In Oracle, there is a Oracle database. Okay. TNS listener. Port number is there 1521 kind of stuff. This is just for an understanding. Okay. Just for understanding, there is a different type of protocols and port numbers. Okay. For example, you take a Tomcat. Tomcat is a web server. The web access is 8080 port number by default. Okay. So protocols, port numbers, there's so many are there. Some are can be changeable. Different port numbers they can use it. Okay. And some are dedicated port numbers are there. I given a list of these protocols up to SNMP. These are a dedicated port numbers. Dedicated port numbers. The port number may changes if it is over SSL kind of stuff. Okay, like SNMP, POP3, IMAP. Over SSL, the port numbers can be changeable. These are the protocols, guys. Simple to understand. First of all, protocols and port numbers. What is the protocol? To understand what is the request from client and a servers. Request or a response from clients and servers. From clients and servers. Okay, so client to server, server to client kind of stuff.
Sir.
It defines what type of communication it is. It defines what kind of communication it is. Yeah, tell me.
Sir, for every protocol, a port number is fixed.
There's some for certain protocols, port number is fixed. Fixed port numbers, but over SSL port number will be changes like this: HTTP, HTTPS. port number changes like that. Okay. Like this, we can add so many type of protocols and their port numbers. So many are there, but just I'm giving only small list of protocols and port numbers. So here I'm going to start with the application layer. Okay. Application layer is also dealing with this protocols and port numbers. And not only that one, application layer is a top layer of a OSI layer, guys. At application layer, for example, I am using a web browser to send a request to a web server. I want your web page. So this is a web browser. I open a website. I put a protocol HTTPS in the URL and I told which is my remote server and I'm sending a request where in a web browser. Web browser is nothing but an application. So in application layer, actually we are dealing with a client and server side applications. And of course there is a protocols. Of course it will understand what, based on your protocol, what port number should be used. Client side applications, server side applications. Example, I want to access web related. So I need a web browser. I can't do web browsing in a command prompt. I can't use Outlook for a web browsing, right? So I'm using a web browser to access web pages. But other side, remotely, they need a server is web server. We are a client and there is a server. Different applications, they use it. For example, Microsoft IIS, Internet Information Service, HTTPD, Tomcat, or application server like a Tomcat, Gradle, not Gradle, sorry, NGNIX, something is there. Okay, so different web servers are there. See, from client side, application is web browser, and server side means it is a web server with a certain applications or built-in packages, application related. Outlook is a mail client application, so I can able to send and receive a mails through my Outlook application client side. Okay, server side, it is a mail servers are there. So you buy mail servers, how it is become mail server? By installing a Microsoft Exchange application, Zimbra application, the Dovcat application, Squirrel mail application. So there are a lot of mail applications, mail server applications. So application side. Putty, I will show you the putty here. This is also an application. This is also an application. Microsoft Teams is an application. This is the putty. So using this application, I can connect remote machines using SSH or TELNET protocol. TELNET protocol or SSH protocol, I can connect remote devices. Okay. So I will show you FTP, FileZilla. So this is a FileZilla application. So I want to access my remote FTP server. I want to upload or download a files from application. So I can use this application. This is a remote server IP address or a name, username and password to access and a defined port number. So you can connect it. So you will get their remote system. So we can upload and download the data. Same it goes for one more is there, maybe WinSCP. This is also an application to upload or download the data to remote PCs with different protocols. Not only FTP type, also SCP, FTP, SFTP, VSFTP type of protocols also we can use it. Okay, FTP, RDP, Remote Desktop Protocol, MS, TSC. This is the remote desktop related connection. So remote desktop connection. You have to give remote machine's IP address and the username and click connect. And it was password, give the password. So you can access remote machine at from your computer. So remote desktop connection application it is. So application means application layer is dealing with the client side application and as well as a from server side applications also. The sound 5%. Yes, understand? And also their protocols and port numbers also. Sound. Okay. Sound. Sorry. This is what I'm trying to say. Application layer is dealing with the client side and server side applications, their protocols and port numbers also. This application layer. The next two layers is a presentation layer and session layer. The first one is presentation layer. When you are sending a data, okay, or receiving a data, your presentation layer, what it do when it is sending, it encode your data. Means it convert whatever the data format, it convert into ASCII format. Okay, American Standard Code for Information Interchange. Okay, that is ASCII format. Whatever the data you are sending, either it is a text format, HTML format, JPG format, whatever the data format it is. So it is video format, right? Whatever the data format it is, it convert to ASCII format. That is called encoding. While you are sending, encode. When you are receiving, decode. Compressed data, huge amount of data will be compressed to send data very easily. Decompress means when you receive a data will be decompressed. Encrypting, so we already discussed what is encrypting, right? Means when you are sending a data, you encrypt the data, so then anyone is trying to capture your data and try to read what is the data you are sending or receiving. Data is in the encrypted format, so people cannot able to understand directly. Okay, so whenever you receive the data, data will be decrypted at your PC, not in the network. Session layer is, it will create a session and maintain the session and terminate the session. What is this session layer will do, guys? So when you are sending, a session ID will be created. Okay, when is a session layer is, no, what it will do, it will combine all the data together and create as a one single session. Okay, so as per the requirement, so it will create a session. So you transmit the data, then when you receive a data, you complete a set of request and response within a single session only. Okay, how to assemble and how to do it, session will be there. I'll give you only one example for a session layer to understand. Guys, when you buy something, Amazon, you went to Amazon or a Flipkart, you add items to your cart. Okay, now in a cart you have your items. Now you go for a buying, so you go buy, right? So then order placements is happen, right? So you select an address and a payment. Once you given a payment related details and click OK, and you have to give OTP, click OK, then it will wait. Once transaction completed, so you will get a payment successful and go back to your confirmation. Yeah, product is confirmed, placement is confirmed, right? But if you observe from when you are doing this payment time, you are giving your card details and next OTP details, okay? Then you wait. If you observe there, it shows do not refresh or do not press the back button. Why? When you do this refreshment or you press the back button, the session is changes. Automatically you went to different session. And your transaction is there, no? Your payment transaction is happened with one session ID. Only single session. It means total transaction must be completed in single session ID only. But you do refresh or you press the back button, the session ID changes. So if session ID changes, means your request go to bank, money is cut from the bank and it is transferred to Amazon. That part will get confused. Sometimes your transaction successful, sometimes transaction failed but money is detected. Transaction is failed but money is detected. Okay, so that's why I said do not refresh or press the back button. So session layer will create a session when you are transmitting a data until it will be there you receive a data. But any network related disturbance occurs. Yeah, okay, network related disturbance like internet is disconnected suddenly, network is down or some disturbance happens, the session will be terminated automatically. Of course, there is having some seconds of time. Within the time it is connected back, no problem. But if network is got disturbed, so obviously it will terminate the session. Okay, this is a session layer. And the next layer is a very big layer, guys, that is called a transport layer. Okay, remaining are small layers only, but transport layer having a TCP, UDP, that will take little time. But I don't cut today. Okay, just like last class only have done. Because this is completed, maximum your networking part is completed, so then you can read, you can practice part. Okay, this is a transport layer. Transport layer provide end-to-end connectivity. Transport layer segment the data. Transport layer do the segmenting the data. Simple. I have a example called hello world. Sorry, not hello world. Hello, how are you? Hello, how are you? Hello, how are you? So I have a data is there. I am segmenting means I chop the data into small parts. That is called a segmenting because I cannot send huge amount of single data at a time. It is difficult. So I chop the data into small pieces. Maximum size of the piece is 1500 bytes. Bytes, not kilobytes. Okay, bytes only. Each data is that maximum size is 1500 bytes. And I put a numbering on it just for our understanding. I am keeping a number like this. This is numbering on each and every packet. Just for our understanding, guys. So segment the data and numbering and sequence. What is the use? Think like this. This is my source and this is my destination, A and B. Okay, I send a packet one, so B received and it will give acknowledgement. I received a one. Just for our understanding, I received a one. A send a packet and B and it is send acknowledgement saying that I received two. A send a packet, B not received it. It does not send any acknowledgement. A send a packet, means the destination received it and give acknowledgement that it is received that packet. Now at B, it is assembling a data. First packet received, second packet is received, and next received is U. Okay, next received is U. So something is missing, and source understand this is the missing point packet. This is the missing packet. Source understand this is the packet is not delivered to B. How? Because A not received acknowledgement. A didn't receive acknowledgement for third packet. It understand B didn't get it. So then it will send packet and it is received. So B given an acknowledgement for this packet. Now what is the next packet I received? Like this. This is the first one, second one, fourth one, and third one. In this order I received. Problem, right? It is not correct order. Because of this numbering, what destination will do? It reorder again. It will reorder again. Okay. It will reorder again. So once all packets are collected, it reorder the data into things. Numbering and sequencing. So it is used for order and it will do error correction. What is error correction? Nothing. We miss some packet. The packet, the A understand there is a missing packet is happened. Okay, B didn't receive a particular packet. So it will resend the packet again. It resend the packet again. And it will rearrange the packets in order properly. So this is called a error correction tool. So it's provide end-to-end connectivity. It's segmenting the data, means chop the data into small pieces, numbering and sequencing. Okay, like that. And transport layer do error correction, means any missing packet is there, it will resend again. It multiplex and demultiplexing of protocols TCP and UDP. Lot of people get confused. It is a separate part, guys. This is also an important point in your networking. No. This is TCP and UDP. TCP means Transmission Control Protocol. UDP means User Datagram Protocol. In application layer, before starting of application layer only, we discuss protocols and port numbers, which is actually part of application layer. Have you seen these different protocols, guys? Some protocols are TCP type protocol, some are UDP type protocol. Some protocols are TCP type, some are UDP type protocols. TCP type protocols are behavior is acknowledgement based behavior. Acknowledgement based protocols. TCP type protocols are acknowledgement based protocols. Okay. So source send a packet to the destination. When destination received a packet, it will send an acknowledgement. Source send a packet to the destination. If destination does not send any acknowledgement, source think destination is not received. I'm changing a little pattern here. So source send a packet, destination received a packet, destination send an acknowledgement to the source. Next, if source does not receive a packet, source destination does not receive a packet, it does not able to send an acknowledgement. All and nothing. Okay, if source send a packet, destination received, so the destination will send an acknowledgement. The source received an acknowledgement means destination received a packet. What I'm doing is any missing packet, if the second packet is not received by destination, I thought because of the source not received a acknowledgement for source not received acknowledgement. Source not received an acknowledgement for a packet number 2. So source think destination is not received a packet number 2. So what source is doing? It send the packet again. That is a TCP type of protocols will do. Example HTTP, SMTP, SNMP, FTP. These protocols are TCP type protocols. Then what is UDP type protocols? Example DHCP, TFTP is the best example for a UDP type protocol. What it will do, it send a packet to the destination. Whether destination is received a packet or not, will send a packet. For example, here the third packet is not received by destination. We don't know, the source don't know destination is received a packet or not. Again, source send a packet to destination and source don't know the destination is received a packet or not. That is UDP type behavior. That is no acknowledgement. There is no acknowledgement here. Certain protocols are these protocols. Some protocols are UDP type. Example TFTP, DHCP. Because it's not using acknowledgement and source don't know the destination received a packet or not, that's why UDP type protocols called a non-reliable and connectionless protocol. Guys, remember, connection oriented, connectionless does not mean wired or wireless. No wires, no wireless concept here. Connectionless means source send a packet to destination and source don't know destination is received a packet or not. That's why it is connectionless, one-way direction. One way, I don't know whether you understand or not. Connectionless class. What is connection oriented? Connection oriented means source knows destination is received the packet. How it will knows? Based on the acknowledgement, because I am getting acknowledgement from the destination. That is called a connection oriented, and it is a these protocols are reliable protocols. Guys, this is about your TCP and UDP. Transmission control protocol, user datagram protocols. Okay. Flow control and windowing. Guys, I can send I am sending some packets. I am sending a 10 packets to destination. So I will tell to the destination I am sending 10 packets, count it properly. Okay. So that's called windowing. I am sending 10 packets at a time instead of sending one packet. So I send 10 packets at a time. Destination receives all packets. So then it will give acknowledgement for all packets at a time. So instead of send one packet, wait for acknowledgement, send another packet, wait for an acknowledgement, send another packet, wait for an acknowledgement. Instead of that one, windowing and flow control, I will send a bunch of packets at a time. The destination receive the packets one by one, and it will give acknowledgement for the bunch of packets. So that's why I written the second, third, again it is like this. Okay. Just for space purpose, I have separately written like this. Okay, and This is PDU, guys. What is PDU? PDU, packet data unit. PDU means packet data unit. What is the PDU, packet data unit? The data in the layer, what are the data type, what are the data form of the data in the here. So it is called a PDU. In application layer, the application layer data, what are the data it is called a PDU. The PDU in application layer is nothing but a data only. From application layer, from what are the application layer data is called data only, the data, that is the PDU. Same presentation layer, data is encoded, compressed and encrypted. So that is your form of data, right? The data we call it as a PDU here. Packet data unit. So, but the packet data unit is not data now, it is the name of the packet data unit will changes at transport layer. How? Because there are some additions will happen here. TCP header is added to your data, which is came from the session layer. Data is transferring from application to presentation, presentation to session layer to transport layer. In transport layer, TCP header is added to your TCP header is adding. The total data outcome of transport layer we call as a segment. What is this segment contains? The earlier data, the data plus protocols, TCP, UDP, multiplexing information, windowing information, numbering, segmenting data, this data information in your TCP header. This segment is sent to network layer. The next two 3 layers are simple layers only. Okay, simple layers. If you have extra time, then I can add only in single class about troubleshooting also, but we'll separately discuss that part. So this segment, the segment is sent to the network layer. In network layer, we have two things. One is routed protocols, means logical addressing. Logical addressing, like a different type of logical addressing is there. Example, IP address, IPv4, IPv6. And routing protocols also dealing in a network layer. So you want to send a packet from one to another one. You are sending packet from your system to some destination. The packet also should have a how to go to destination. That is routing path, right? Knowing which direction you have to go. Routing protocols. What is network? Okay, routing protocols. So this is two things in the network layer. Network header is added to your segment. That is called a packet. So data, the PDU from network layer is called a packet. We are using every time this packet, that packet, but not exactly it is. Originally the packet, the original packet name packet is the outcome of network layer. What is this network layer header adding? It is a source IP address and destination IP address. Packets sent to data link layer. Packets sent to data link layer. Okay. So what it is adding, guys? So from network layer we are getting packet. The packet contains segment, which is from network layer, and source IP and destination IP address is added. What is the next layer after network layer? Data link layer. What is this data link layer is dealing? Data link layer contains two main layers. One is LLC, logical link control. Another one is a MAC layer, because of data link layer, the name is MAC layer is there. So that is why it is called a switch is called as a layer 2 device. Switch is called as a layer 2 device because the MAC address understands at data link layer. Router is called as a layer 3 device. Why? Because of router can able to understand IP address and routing protocols. So where is located? In network layer. That's why router is layer 3 device, switch is layer 2 device. This is logical link control is belongs to WAN protocols dealing with the WAN connectivity. When you are sending your packet over any WAN connectivity, that is different WAN protocols. So you are connected to WAN means you have to use WAN protocols. Okay, where it is located in data link layer, LLC logical link control. Media access control is also part of data link layer, another layer which is near to physical layer. It contains the MAC address is 48-bit represented in 12 hexadecimal number, also called as physical address, which we are already discussed. In data link layer, so it is added with the data header to the packet and data tail. There is source MAC address. Destination MAC address will be added to your packet, and there is a CRC. The total we call it as a frame. What is CRC? Cyclic redundancy check. Error checking. Where error correction happens? Transport layer. Error checking happens at data link layer. Guys, CRC is an algorithm used to check data. It is used to check data. Is data is good or corrupted? CRC is an algorithm used to check the data, whether data is good, data is corrupted. So the outcomes, the source MAC address, destination MAC address is added to your packet plus CRC. The total one is called a frame. This frame is sent to your physical layer. The physical layer is actually dealing with your physical connectivity, right? Hub is an example because physical layer does not deal with any MAC address or IP address. It's just for connectivity. Different type of connectivities are there in a physical layer, right? So like it can be a Ethernet type or maybe Wi-Fi type or fiber optical type of connectivities. So your frame from data link layer is converted into bit stream. The bit stream again convert into different signals like a electrical signal, radio wave signal or a light wave signal. Okay. So this is your physical layer. Of course, there is a comparison what is 7 to 1 or 1 to 7 type of communication that is there. Plus guys, tomorrow I will tell few points TCP, OSI and TCP IP comparison, OSI voice troubleshooting. Actually, I'm avoiding this voice troubleshooting from so many batches, but this time I will try. Voice troubleshooting also. Tomorrow I will complete that one. Then we'll go to the any other classes. Okay. This is up to now. Okay. Guys, understand somewhat about OSI layers? Application layer, presentation layer, session layer, transport layer, network layer, data link layer, and physical layer. Yes. Okay. So protocols and port numbers. Different protocols are there. Protocols having their own port numbers. Each protocol represent a particular service or particular type of communication. HTTP, HTTPS, FTP, SSH, TELNET, RDP, SMTP, POP3, IMAP, TFTP, DHCP, DNS, NTP, Kerberos, LDAP, SNMP, like that different type of protocols are there. Okay, application layer actually dealing with a client or a server side application protocols mainly protocols. Okay, application layer wise. Presentation, it encode the data, compress the data, encrypt the data while sending, and when receiving, it is decode the data, decompress the data, de-encrypt the data. Session layer will create a session and maintain a session and terminate the session. So entire your one set of communication is actually dealing with the session layer only. Transport layer provide end-to-end connectivity and also to do error correction. It segment the data, numbering and sequencing, and multiplex, demultiplexing of TCP and UDP type protocols. Okay, flow control and windowing. Okay, and the data TCP header is added to our PDU, that is called a segment. The transport layer outcome is a segment. TCP UDP protocols, TCP UDP, our protocols are divided into TCP type or UDP type or both. TCP type protocol is acknowledgement based, UDP type protocols are no acknowledgement based. In TCP type protocols, source knows destination is received a packet. How? Destination is send a acknowledgement to the source. So connection oriented, connectionless, because of source knows destination is received a packet. Connection oriented, connectionless, source don't know destination is received a packet. Network layer, the network layer, okay, it dealing with an IP addresses and means routed protocols and routing protocols, like dealing with logical addresses, example IP addresses, and different routing protocols also. Routing protocols will create a routing table and tells how to reach the destination. This network header means source IP, destination IP is added to the segment, then we got a packet. The packet is sent to the data link layer. Okay, the data link layer having two sub layers, one is LLC, another is a MAC layer. LLC dealing with a WAN type of protocols like a PPP, SDLC, frame relay kind of protocols to connect in WAN communication. And MAC layer is MAC address will be added to your packet. Source MAC address, destination MAC address is to add it to packet plus CRC. CRC, cyclic redundancy check, is an algorithm to check errors. Okay, the total PDU we call it as a frame. The frame sent to physical layer frame convert into bit stream again convert into electrical signal, radio signal or light wave based signals. Ethernet, Wi-Fi kind of connectivity, fiber channel connectivity we are using. So your frame is convert into a particular signal. It depends upon what media, what type of connectivity you are using. Okay, so in generally, so there is a OSI layer. In the OSI layer itself, there is a from application layer to physical layer to application layer is there. So if you read from bottom to top, it is physical layer receiving type. Okay, and there is a comparison TCP UD comparison. This one I will tell tomorrow. Okay, guys.
Okay, sir.
Good.
Okay, sir.